All right, so we're going to continue with our reactions lab here. This is station number 2. What we started with here is this compound here, cupric sulfate. You have the formula right there, CuSO4, .5 water. We remember that .5 water represents that this is actually in the hydrate form. Notice that as a hydrate, this thing here is a solid. So you can imagine with my ionic lattice here, let's imagine the green represents the copper, let's imagine the blue represents the sulfate here. We know ionic compounds here end up forming this lattice where it repeats positive and negative here. You'll notice in the solid form, like a sponge can hold water, water can actually get soaked into these tiny little pores. So when you actually look at this chemical here, it's actually saying for every 1 copper sulfate, there's actually 5 times the amount of water that's actually embedded inside the structure here. Again, the emphasis here is it has to be in the solid form. For this reaction here, what we've done is we've taken the copper sulfate, we've added some water to it to actually dissolve it down. The concentration of this one here ended up being 0.5 molar copper sulfate. So what you can imagine here is this ionic compound actually, because it got dropped into water and being soluble, this thing here completely ripped apart. It started falling apart here. All that water that used to be in the pores here when it was in solid form here, all of that's gone. So when I actually have this chemical here in solution, this is actually just a pure solution of just copper 2 ions and sulfate ions. That's what we're going to be starting off with in this reaction here. I'm going to demonstrate this inside a test tube. We're going to watch the reaction as iron gets dropped into this copper sulfate solution. So I'm just going to fill up this test tube a little bit here. Okay. So copper sulfate, it's already in solution here. It's no longer in the hydrate form. We have a piece of iron here. This is our iron nail. It's been used in previous years, so that's why it's been covered with a little bit of soot there. So what I'm going to do here is I'm going to take a piece of steel wool. It acts sort of like sandpaper here. What you can do is you can just scrape down some of the outsides here. You try to reveal as much of the iron as you can so that the iron is exposed to the copper sulfate solution when you actually drop it in. So the hope here is because the nail is fairly long here, as I drop it in, part of it's going to be covered in solution, part of it's going to react, part of it's not going to react here, and that way we can compare the before and the after. Okay? This reaction usually takes about 10 minutes or so, so what I'm going to do is I'm going to switch over to do a time lapse of this picture here, and then we're going to have a quick look at what happened to the nail afterwards. See you in a bit. Okay, so we're just going to finish up reaction number 2 here. I actually left this nail here over the day, so it's been about 4 or 5 hours here. We're just going to make some observations here. You notice that the coloration of the blue copper 2 sulfate is not quite as intense. It's gotten fairly light here. We left our iron nail here. The top portion here had not been in contact, so that should still be pretty normal to what it started off with. It's mainly this part here on the bottom here. You already see a little bit here inside the test tube. Just gonna use a pair of tweezers here to grab this nail out so you can have a closer look. So with this nail here, you notice here quite significantly different from what we had before. We've sort of lost the grayish silvery metallic surface, and it's now been coated with a more reddish looking material here. Towards the bottom of the nail here, it actually gets a little thinner. That's where the red material actually built up quite a lot. I'm just going to leave this nail here down. We're also going to just sort of look at the solution here. You'll notice that previously the solution had been clear, but you notice now that there's actually a lot of solid that's actually formed in solution. So I'm going to demonstrate for you a technique here. The reaction is actually already done. We've already made our observations. What I can do here is sort of like a technique in filtering here. Instead of using a filtering paper, what we're going to be using here is a process called decanting. So I just have a beaker here. What I want to do here is I want to get the liquid here, just toss it into this beaker, but I want to keep all the solid if I can inside the test tube. So what you're going to do here is you're going to pour this test tube here. We're going to pour the solution slow enough against the side of this glass stir rod. The liquid is going to fall down where the stirring rod is pointed, which is into this beaker, and I'll hopefully be able to trap all the solid here inside the test tube. So again, this process here is known as decanting, especially if the solid is very fine, which in this case here, sure, there's still a few grains that might end up inside the beaker here, but hopefully the stir stick here will try to keep that minimal, and then therefore we would have the solid material at the bottom here. I'm also going to demonstrate for you what's referred to as a flame dry here. In case I wanted to weigh this material here, what you could have done is you could have weighed the test tube beforehand, you weighed it after it's dried. By doing a subtraction, you can figure out how much solid is present. Okay, so we're going to switch over to do that. Okay, and just showing you what a flame dry could look like here. So I pulled out our Bunsen burner here. I'm just going to strike our Bunsen burner. Okay. Currently it's on the blue flame setting here. It's almost invisible to the naked eye here. You can twist it back to an orange flame here. I don't need it overly hot. Because I'm going to be holding this test tube here over top of the Bunsen burner, you don't want to be holding it with your hands. I'm just going to lower the flame a little bit here. I'm going to take a pair of test tube clamps here. We're going to grab the test tube, and again, it's a very quick, just sort of moving it around. Again, making sure you don't point the open end here towards yourself here. I don't want any soot developing here on the test tube as well, so I'm just going to do a quick flame dry like this. Hopefully you can evaporate off some of that leftover liquid. You could also leave it overnight here, let the rest of it evaporate, but this is just a slightly quicker method in trying to dry it off. You would wait till it is cooled down a little bit here, and if you were interested in figuring out how much solid was left over, we can just weigh it at that moment. Okay, so there's our example of a flame dry. I'm keeping this moving here so you not concentrate the heat at any given area here. If you're worried about fumes here, you can definitely do this inside a fume hood as well. Okay, thanks guys.